Hello friends, welcome to the second session of the Fibonacci series problem solving. In this session, we will look at various ways to solve Fibonacci series using computer science and programming. In the future video or videos, we'll try to unify the philosophy of reason and understanding with math and the philosophy of judgment with data science and algorithms to understand Fibonacci series and solve it in the most optimal way that is possible, and some thoughts, hypotheses beyond to further optimize. So let us look at a simple recursive solution. Let's say we have public int. I'm going to call the function name as fib for simplicity, and is int I. If I is equal to 0 or I is equal to 1, we're going to return I. So this is the base case, because 0, 1, 1. So when I is 0 or 1, we just return these two. When I is 2, we return 0 plus 1, 1. When I is 3, we return sum of these two, which is 2. So on and so forth. So let us look at the recursive case. So in the recursive case, we want to return fib of I minus 1 plus fib of I minus 2. So this is the solution. But there's a problem with this solution with respect to the time complexity and the stack space that it uses. Let us look at the code path to correctly understand what's happening with the time complexity. So let's take an example of fib of 5. We want to generate the fifth Fibonacci number. So it's going to branch out to fib of 4 and fib of 3. This is going to branch out to fib of 3 and fib of 2. This is going to branch out to fib of 2 and fib of 1. This is going to branch out to fib of 1 and fib of 0. This is going to branch out to fib of 1 and fib of 2 and fib of 1, fib of 2 and fib of 1. So we keep doing this, going to the code path till we reach the leaf nodes, which is the base case, that is 0 or 1. So this is the base case, this is the base case, this is base case. So this will be fib of 1 and fib of 0. So this will be fib of 1 and fib of 0. So we have completed. So what is the time complexity? So if we look at this, the root has 2 children. And these 2 children has 4 grandchildren. And these 4 grandchildren will have 8. So it's 2 power 0 here, that is 1, 2 power 1, that is 2, 2 square, we have 4, and then 2 cube, 8. So if there are n nodes, it's going to be 2 of n, or the branching factor is 2, because there are 2 branches, times the height. The height is the number of nodes of the tree, is to be to order of 2 power n. This is a very costly operation. Technically it's 2 power n, but practically at runtime it's slightly better than 2 power n. It's going to be order of 1.6 power n, because it's not a balanced tree, because it's going to be skewed to the left side, because fib of -1 is going to grow more because it's going to do just subtract 1, then fib of minus 2. Minus 2 is going to be on the right hand side, on the right node or the right child of the node is going to grow faster. So it hits the base case sooner. So it's going to be skewed. So at runtime, it's going to be probably closer to 1.6 power n, but still saying 2 power n is correct. So this is a problem and this is a simple case. Let's look at optimizing this with more scenarios and better solution using more space and then variables, and then finally we'll look at the most optimal solution that is possible along with unifying philosophy of understanding with reason, math, philosophy of judgment, problem solving. Thank you so much for watching.